Okay, first we're going to take a look at the Firewall NAT, let's say, implementation options, starting with 8.3 code, and then we're going to go to the actual configuration of both NAT types. So Firewall NAT overview, starting with ASA 8.3 code, we can, configuration-wise, we have only two NAT types that can be configured. Object NAT, it's also known as automatic NAT, due to the automatic order of NAT rules by the ASA. Gonna get also there a bit later. And twice NAT, which is also known as manual NAT, due to manual order of NAT rules by the administrator. So it's known as object NAT is known as auto NAT because the ASA is gonna somehow, we're gonna see exactly how it's gonna automatically order the NAT rules, the object NAT rules. While twice NAT is also known as manual NAT because the NAT rules are manually ordered by yourself. Now also, as you're going to see, object NAT is called object NAT because the NAT configuration happens inside an object, and twice NAT is called twice NAT because this kind of NAT configuration allows you to do double NAT or twice NAT. Allows you to NAT at the same time in one single rule both the source and the destination of an IP flow within one rule. So both object NAT and twice NAT support static NAT, static path, dynamic NAT, dynamic path. Both of them support those NAT options. Twice NAT has additional capabilities. As we said, per the name, it allows the translation of both source and destination via a single NAT rule. That's why it's called twice NAT. And also because it's twice NAT where we can match on both source and destination. And you can optionally NAT either the source, either destination, or both of them. Also, only via twice NAT, policy NAT can be configured on the ASA. That is because, as you remember, policy NAT means that I'm going to NAT traffic in a specific way based on I'm going to NAT an IP address into something specific based on the destination of the IP traffic. And it makes sense that this can only be achieved via twice NAT because only in the twice NAT rule configuration, as you're going to see, you can configure both the source and the destination of the IP flow and choose to NAT only the source, only the destination, or both of them. So if you remember from the iOS, when we went to the NAT types on the iOS, like static NAT, dynamic NAT, policy NAT, we stated that policy NAT means that, for example, if traffic goes from PCB to router 3's loopback 0, I want to NAT PCB into an IP of X. While if traffic goes from PCB to the ASA, let's say to router 3's IP address on VLAN 38, so if destination is being different, then I want to NAT PCB into Y, into something else. So based on the traffic destination, I want to NAT the source differently. That's policy NAT. And it makes sense that this can be configured only with twice NAT because only twice NAT, as you're going to see configuration wise, allows you to match in a NAT statement both on the source and on the destination of the IP flow, and you can choose if you want to NAT the source only, the destination only, or both of them. So again, I'm saying this because you should memorize nothing, absolutely nothing. You should understand why, you should make a logic out of everything. Now, order of operation. So ASA automatically groups NAT statements into 3 sections. In section 1, we're going to have the manual NAT or the twice NAT rules. In section 2, we're going to have the auto NAT or the object NAT rules. And in section 3, we're going to have after auto manual NAT rules, like twice NAT rules. So the manual NAT statements can be seen by let's say the ASA is going to put the manual NAT statements either in section 1 or in section 3. We're going to speak about both of those sections in a couple. But by default, the ASA, so it groups all NAT statements into 3 main sections. Section 1, manual NAT. Section 2, auto NAT. Section 3, after auto manual NAT. And when the ASA has, when traffic flows through the ASA, and the ASA is going to inspect what kind of NAT does it have to do, top down is the exact order that ASA will inspect NAT rules for traffic translation. So what this means is that as traffic flows from PCB to the loopback router tree, this way to the ASA is going to first look in section 1, which is the manual NAT entries. It's going to see, do I have any manual NAT entries which matches on this traffic flow? If yes, I'm going to NAT the traffic as in the manual NAT configuration. If not, then I'm going to go in section 2 and say, does this traffic flow match any of my auto NAT entries, which are the object NAT entries? So then I look in section 2. If my traffic from PCB to the internet router tree matches on any of the auto NAT rules, I'm going to do what the auto NAT rules are telling me to do. If not, then I'm going to go in section 3, which is the after auto manual rules. And I'm going to say, does my traffic flow match any of the NAT rules in section 3? If yes, I'm going to NAT traffic as configured in section 3. If not, I'm going to choose not to NAT the traffic and route it as it is. So that's why I said that the ASA is going to inspect section by section, top down, and of course stop on first match. So if the ASA is going to match with the traffic flow on section 1, it's going to NAT traffic as section 1 states, and that's it. If not, if it doesn't match with that traffic flow, if that traffic flow doesn't match on section 1 NAT configuration, then it's going to look in section 2. If the traffic flow matches any of the NAT statements from section 2, it's going to NAT the traffic as section 2 states. If not, it's going to look in section 3. If traffic policy, if that traffic flow, if that IP flow matches any NAT statements from section 3, it's going to NAT the traffic as section 3 states. Otherwise, it's going to do no NAT on the traffic on the IP flow and just route the packet. Now, of course, we can have multiple entries in each of those sections. In the manual NAT sections, there is no preference between static NAT and dynamic NAT. Order of configuration by default is the order of inspection. So what this means is that in section 1 and section 3, which both of them contain manual NAT entries, let's take section 1. Let's assume we have 2 NAT statements in section 1. In section 1, we have 2 NAT statements. The first NAT statement is of type dynamic, which states to NAT, let's say, to put it in simple terms, the first NAT statement says to NAT PCB into an IP address of X. This is a dynamic twice NAT configuration, dynamic twice NAT rule. And then the second rule says to NAT PCB into the address of Y. And that's a static twice NAT rule. Because that's the order of configuration, rules number 1 and number 2, the ASA is going to parse section 1 entries top down and stop on first match. Which means that because that's how we order the configurations, the dynamic NAT is going to happen for PCB's traffic and not static NAT. So in the manual NAT sections, we're going to have multiple, of course, entries in section 1 and section 3. And in both of those sections, there is no preference of static NAT over dynamic NAT. It's just the order that you configure the rules in, just like in an ACL. Top down, I'm going to stop on first match, and that's it. Now in the AutoNAT section, which is section number 2, static NAT rules have priority over dynamic NAT rules, always. So what that means is that if we had the same example as before, we had one dynamic, but now one dynamic NAT entry and one static NAT entry. But now this was not section 1, this was actually section number 2 for AutoNAT. So if in section number 2, let me use still black. If in section number 2, which is the AutoNAT rules, we had rule number 1, which stated to NAT PCB into X, and that was a dynamic object NAT rule. Dynamic object NAT rule. And then secondly, we configured that PCB NATs into Y, and that was a static object NAT rule. So for section number 2, order of configuration doesn't matter. The ASA is going to automatically reorder the rules and make sure that in this case, if my traffic flowing from PCB to whatever, if that traffic flow matches on section 2, doesn't matter how I've configured those two NAT rules, PCB NATed dynamically into X or statically into Y, order of configuration doesn't matter. Always static NAT is going to take precedence over dynamic NAT, which means that in this use case, I'm gonna NAT PCB statically into Y. I'm gonna NAT PCB statically into the address of Y. So in section 1 and 3, order of configuration is important. There's no preference of static NAT over dynamic NAT. In section 2, order of configuration is not relevant. Always static NAT is preferred against dynamic NAT. And again, it's a confirmation of the fact that AutoNAT in section number 2, the ASA automatically orders the NAT statements. It gives preference to static over dynamic entries. While in twice NAT, which is manual NAT, you tell the ASA what to prefer by the order of configuration. Which means that if in the manual NAT configuration you have first configured a static NAT and then a dynamic NAT for the same traffic flow, static NAT will happen. If you first configure a dynamic NAT and then a static NAT for the same traffic flow via manual NAT entries, then dynamic NAT is going to happen to the traffic. So that's why twice NAT is called manual NAT, because in that section 1 or 3 you manually order the order of rule interpretation by the ASA. It's going to make also hopefully much more sense when we go also to the configuration side. Now, default sections for NAT configurations. So section 1 is the default location for manual NAT statements. So when you configure a manual NAT statement, the ASA is going to by default allocate that into section 1, while section 2 is the default location for AutoNAT statements. So whenever you configure a AutoNAT state configuration, object NAT configuration, ASA is going to add that statement into section number 2. Optionally, only manual NAT statements can be configured as a member of section 3. Now, why would you do that? In general, this is used as a gateway of last resort for traffic not matching on section 1 or section 2, which you still want it to be NATed. In some design use cases, we could make use of section 3, but in general it's rarely used. In general, in most use cases is never use section 3. In most use cases we deal only with section 1 manual NAT entries and section 2 object auto NAT entries. We pretty much see very rarely configurations which makes use of section 3. As I stated, one use case would be that, for example, let's say that you configure your policy so that, for example, for traffic from the internet coming into this server, because this server doesn't have a public address, or for traffic coming from the internet to the ICE server, likewise because ICE doesn't have a public address. Let's say that for ICE and server A, on the ASA you're going to configure static object NAT, which usually this is what is being used in general. So to publish services out on the internet, usually you're going to make use of object NAT configuration and of course of static object NAT configuration, because you want that those services to be publicly available at all times. So you do static object NAT for those services, and then when you want to allow internet traffic from the users, so you go inside outside, you can do dynamic object NAT or dynamic twice NAT. And of course you usually don't do dynamic NAT, but you do dynamic path. So either way, you do dynamic path by using object NAT configuration or twice NAT configuration. So it means that in general you're gonna have section number 1, let's say section number 1, which is the manual NAT entries, where you're gonna have like dynamic path configuration, dynamic path for internet access from the users. You're gonna have one or multiple entries in there. In section number 2, you're gonna have static path or static NAT entries. So object NAT configuration in section number 2, static path or static NAT for publishing in the internet, for publishing in the internet services like your public servers. And then we're gonna sometimes, as I stated, in general this is good enough, you're gonna make use of section 1 and section 2. So section 1 to get internet access, dynamic path; section 2 to do static NAT path for your services, your public services. And section number 3, for example, you could put in here a additional like dynamic path configuration. Use case being, for example, that if traffic flows through the ASA and that traffic doesn't match on section 1 or on section 2, but you still want to NAT the traffic, then you're gonna fall back on section 3, on like a gateway of last resort, on that default dynamic path rule, which NATs traffic into whatever, XYZ. So the section number 3 has some specific use cases and some designs, but in general you're gonna not see that in a lot of use cases. Now ASA for all objects. So the objects have been added alongside with NAT changes in A3, and it's required for object NAT. It can also be used like object groups for ACL optimization. Can be used in ACLs instead of host mappings. And per the name, an object can contain a single entry or a single object, thus the name, as opposed to object groups, where in object groups you could configure multiple entries. So an object is going to be a container which can contain only one single entry, not multiple entries like it was the case with object groups, because this is an object, not a group of objects. Object types can be of type network, subnet, range, host, or of type service, which can be protocol or TCP/UDP ports. In general, objects are being used for NAT configuration, either for object NAT or for twice NAT as well. But for object NAT, objects are required. Like, just to confirm what I said before, if you say conft object network, give it a name test, because it's an object network, let's say Christian. This is not an object group but an object. If we say host 1111 and subnet 10.10.10.0/24, the second entry configuration wise is going to override this one, this configuration, because this is an object and have only one entry, and I try to put two entries in there, which means that the second configured entry is going to always override the first one. Which means if we say do show run object, not do show but just show, there we go, it's subnet. If I put back host 222, now this is going to override the subnet command, and I want to see the object now contains only that host. And again, it makes sense. So clear configure object, not object groups but objects of type network. So show run object, I should see no more objects in there. Now, configuration steps for NAT. So we first have to identify which NAT type do we need, static, dynamic, or policy NAT. Then we have to identify which configuration option best meets the requirements, like object NAT or twice NAT. In general, both of them support, as we stated, both all NAT types except policy NAT, which is only supported by twice NAT. And then for object NAT configuration, you define the object and you configure the NAT statement within the object. For twice NAT, you define objects and or object groups to be used in the NAT configuration, and then you configure the NAT statement globally. That is twice NAT. Verification wise, we have the show NAT or show NAT detail commands to verify our NAT configuration, in which section has the ASA added those NAT statements, and what are the NAT statements. Then to verify the translation table, show xlate, we're going to see in there the translation entries. If it's static, we're going to always see the entry in the translation table. If it's a dynamic NAT, we first have to initiate traffic to see the translation in the translation table. That's show xlate. And then to verify that NAT actually happened to a specific connection, we say show connection log or show connection detailed to see that if the ASA has actually matched with the configuration on the NAT, with an IP flow on the NAT configuration, and if the traffic was properly NATed.